diameter of 32.3 because that's the perfect length
No, I'm not talking about that. I'm talking about the concentration of the palladium inside the solution.
Yes.
How did you calculate it? It depends on the length of the tube or the substrate and the outer radius of the wall, which is 14 millimeters is I think the diameter, half of the radius.
Yeah.
And the thickness of your palladium, right?
In the end, yes. Yeah.
So if you
yesterday we weighed our membranes.
Yes.
So after deposition we again weighed our
the
membranes.
membrane or the substrate?
The substrate.
Okay.
Yeah. So after deposition we will again measure the weight, and then we can differentiate that how much palladium get into it.
Right. But how much how much palladium did you put into the bath today?
It is some molar concentration. We don't know it is 1 molar or 0.1 molar.
I know that it's about 57% in the raw material of palladium chloride, 57% pure palladium. So that's the
So if you want to target a larger thickness, then you have to put a larger concentration into your bath.
Yeah, if it doesn't influence your growth, or you can repeat the plating solution. That's what we also did in the past.
I see.
Because sometimes this one is harder to control, and then they asked me take substrates that you would not take the quality, the defect population quality, that are just excluded. So I took a good one, just at the area, a few defects, and I knew where they were, and a few more, and a few more, and then they asked, put a normal layer on top of that, and take some to put a double layer on top of that. Can we plug those defects with the thicker? It is, it can be, and then still I say, yeah, but in the end you put it in a process, and if you have in mind the at temperature and time what palladium is doing, because it's acting and working and moving and etc. And do you really want to have those defects then? Those 30 or 40 or whatever, huh? It can immediately influence your product. So
I understand.
That's why it's good to do it and to know. But don't walk into the trap to use them in the end, maybe, or use them and you know it, but not even question is from the outside world, and by coincidence you have, I still have some palladium left, so I take that one, and you forget your history, and then that's a risk. So that's why I'm always aiming for that line, because then I know what I used as a starting point, and what's in the cupboard must be that good quality material.
So the point is, if you want a thicker palladium membrane, don't put more concentration of the palladium precursor at the beginning, but do it and then for 2 hours and then plate another one without annealing.
Yeah, or
anneal at the end.
I find it hard to say, but maybe if the concentration is higher and your temperature is lower, maybe you end up in the same growth, because it's so sensitive.
Yes.
That I really should make a choice to do that experiment and
really
wrap that together. I'm always confusing because if my colleague Raghu is have to make some material and he's taking it out of the cupboard and I don't see it, and he is not looking into the archive, he always asks of course, but then you end up in a risk in a way.
Right.
And I don't dare to do that. That's why I want to have those codes always unique, etc. I can always trace back the history of something we made.
So on the longer substrates like this and the shorter substrate, the thickness of the film is the same, like 2 micron.
You have always variation because it's a growing system.
Yes.
That's why I say compare it with growing crops. You can for 10 years grow crops of salad or whatever, and over the 10 years you grow it on the same land and you do the same thing, you still have that variation.
Yes, small.
So it's difficult, so you try to get everything as accurate as possible, and that's at least the way to end up.
So, excuse me.
Yeah.
You have, this is a graduated cylinder. Okay?
Yeah.
The bath. Let's say, do you know how large this is? 40 centimeters, is it?
Yeah, about.
Yeah, maybe 40 centimeters.
Yeah.
Okay, so let's say it's 40 centimeters. You put the specific concentration of aqueous solution, palladium, EDTA and palladium and others, right, inside. Now, if you have let's say you have a short one like this, 5 centimeters, I know it's not good for operation, and you have a long one like this that is 30 centimeters,
Yeah.
6 times longer.
Yeah.
So, your palladium is going to go around and around and around until it hits a seed or the extension of a seed and settle. Isn't it that if you have a long one, you're going to have a smaller thickness membrane? Because the part it landed here and it's stuck here. Otherwise, if it didn't find it, it would have stuck here 2 minutes later and make a thicker one and a shorter one. That's the way I think of it. If it's the same concentration in the bath, inside the bath, because it's stochastic. With time, it's like radiation also with inside the alpha inside the uranium. It bangs, bangs, and you know, with probability after some frequency,
Yeah.
breaks through. In this case, it's a crystallization. I don't know. This is how I think of it as a physicist, but I didn't really try it myself. Over here.
I don't know how to answer that. The only thing is that when I make small things or larger things,
Yes.
then and then I compare about 20 centimeters compared to
40.
80 or
Okay.
the big or small bath, that doesn't have a real difference.
Like yesterday you
Difference in statistically growth between balls and circumstances and what you pour in and how to deal with that.
yesterday you put the dummy membrane into the beaker first,
Yeah.
and then you mark up to this 170 centimeter we
Yeah.
should make the solution. So these are things you optimize by your own.
Yeah, I
right?
try to aim always because I have a certain amount of solution compared to the length. That's why I say when you have commercial available bath, because I want to look through, so I need something that's available. I can't make it, and then you have another diameter, and then your amount is always slightly more or less, and that's the same for a small piece. You have your Teflon plugs, and for a long piece you have your Teflon plugs.
Right.
And that's already some influence on the amount compared to the surface, etc., and
True.
filling up.
True.
And for example, in this one, this is slightly more narrow, and then the amount of what I need is slightly above the Teflon plug, so it doesn't reach the surface that easily. So that's also already an influence.
I agree.
That's why it's really, and that's why I wanted to say yesterday for flat plates, for example, I don't want to pour them on the bottom, because then I don't have the temperature or the amount or whatever, or particles well maybe growing and lying on the surface. So I want to have it straight up,
Right.
and then compared to the amount of fluid, then I have way more compared to the surface area plated, way more plating fluid, plating solution. So that's not fair in a way, because you have more available for a tiny surface compared to everything of the rest. So,
but can't you reduce the concentration or something like? Yeah, you can reduce the concentration. I think
it's
put more water. Water is okay.
But then how much palladium is then in the neighborhood of that? It's true. I think it's pretty difficult to tune it exactly.
But make it less unfair.
That's true. Yeah, that's why I say